Hi, I'm Paul. We're doing Leetcode must-know interview questions. Today's challenge is threesome. So, given an integer array, nums, return all the triplets, nums I, nums j, nums k, such that I is not equal to j is not equal to k, I is not equal to k, and j is not equal to k. And nums at I, nums at j, nums at k add up to 0. So it's not that none of the numbers in the triplets can be the same, but the indexes can't be the same. So you can't reuse a number. So an answer like this here, -1, -1, 2, we're okay with that because -1 occurs more than once in the input. So we can use it twice. We just can't reuse a number at the same index. Order of the output does not matter. Order of the triplets does not matter. All right. Example 2 indicates that we may return an empty, I was going to say array, but looking at the method signature here, we're going to return a list. So it is possible to return an empty list. What else? Constraints. The length of the input array can go up to 3,000. Okay. Let's look at let's look at how we might go about doing this. Actually, before we try to solve it, let me mention a kind of obvious approach to this that is not gonna work for us. I mean, it'll work, but it's gonna exceed the time constraints. So why don't we just look at every triplet? In other words, we're gonna have 3 loops. And we'll start with -1. In this example here, we'll start with -1, 0, and 1. And then we'll go -1, 0, 2. And then -1, 0, -1. And then -1, 0, -4. Then we'll go to -1, 1, 2, -1, 1, -1, etc. So it's O of n cubed because we've got a loop in a loop in a loop. How many input elements? It goes up to 3,000. So 3,000 cubed, 3,000 cubed. So we're going to go up to 9,027,000,000,000. All right, that's not going to work. All right, so let's look at an example. These are the numbers from example 1. I added a couple numbers to make it a little bit more interesting. Also, I sorted it. I think, well, this problem is in the 2 pointers group of problems, and I can't think of any way to do 2 pointers without sorting it. So we're going to sort the array, and we're going to start with, we're going to start with the first number in the array. We're going to take a pass through each of the numbers, and we're going to have a nested loop. I mean, it's going to be O of n squared. Input size could go up to 3,000, so that means we could have, on the order of like 9 million operations, but there are some heuristics we can use to maybe speed it up a little bit. And again, I can't think of any other way to do it. So let's start with the first number and then set the pointers. We're going to have a left pointer, and we're going to have a right pointer. Let's see. And then we're going to add up all three numbers. -4, -1, and 4. What is that? -5 plus 4 is -1. Okay, that doesn't work. It's too small. And if it's too small, we're going to move the left pointer. We're going to move it to a bigger number. So we'll move it here. And actually, we can probably implement a check to make sure that we're not moving it to a duplicate number. So let's move it here. All right, now we've got -4, 0, 4. And that adds up to 0. All right. If it adds up to 0, then we're going to move both pointers. We're going to add that triplet to the list, and we'll move both pointers. So we'll move this pointer here, and we'll move this pointer here. All right, now what do we have? -4, 1, and 3. That works also. So that's another triplet that we can use. And again, move both pointers. Now when we move both pointers, they're going to meet at 2, which means we're done with -4 as a number. So we erase that, and then we would move to -1 and start the process over. Get rid of these pointers, and we would have pointers. Let's see. Whoa, I didn't mean to erase the numbers. Here and here. All right, so that should give you the idea. And anyway, let's try to write some code for it. Okay. First step is we're gonna sort. Sort in let's see, arrays.sort, and it's called nums. All right. So that will sort in non-descending order. Next thing is we are going to return a list of integer lists. So we have to create one. So let's say list, list integer, call it triplets equals a new array list. All right, what next? Okay, for loop. This is gonna loop through the input array. So for int, instead of calling it I, let's call it first. It'll make a little bit more sense in the code. Int first equals 0. First is less than nums dot length minus 2, because we don't want to go any further than the the second to last, third to last, not next to last. Well, anyway, we don't want to go past. Yeah, we don't want to go past nums length minus 2, because if we do, we can't get a triplet. Okay, first nums length minus 2 and first plus plus. You know, there's something else that we can do here, and that is, because the array is sorted, if first becomes a positive number, we are not going to get a working triplet. I mean, because we're just going to be adding positive numbers. So another thing we can do here to end this for loop is to say that nums at first, it has to be less than or equal to 0. Okay. Let me spread this out a little bit. Okay. Next, first, well, let's initialize pointers. So we need a left pointer, which is initially first plus 1, and we need a right pointer, which is initially nums dot length minus 1. Trying to think something to do about duplicate first elements. If first is greater, okay, if it's greater than 0. Oh, okay, yeah. Actually, we did this in the example, but what we want to do is if, and this isn't going to happen when, for the first index, when the index is 0, but if it's greater than 0 and the nums at first equals nums at first minus 1. In other words, it's the same number that we just used, then skip it, because otherwise we're going to get duplicate triplets, or we're possibly going to get duplicate triplets. I mean, another way to do this is we can just go ahead and find the triplets and then check when we're going to put them in the list, is this a duplicate? But it's going to be more efficient if we just don't make the duplicate triplets in the first place. All right, so don't use repeating numbers more than once. Now we do the two-pointer technique. So while left is less than right, let's get the sum. Int sum equals nums first plus nums L plus nums R. Okay. If sum is less than 0, then if sum is less than 0, then we need to increment the left pointer. Is that right? If it's less than 0? Yes. We need to increment the left pointer. All right. Else, if, looks kind of ugly there. Let's put it here. Else, if sum is greater than 0. We need to decrement the right pointer. And the only other possibility is that it's equal to 0, in which case we are going to add it to the triplets list. So triplets.add, we'll convert it into a list dot of nums first, nums L, and nums R. All right. When it's when we hit 0, we're going to move both pointers. So we are going to, let's see, left is an increment and right is a decrement. All right. Again, though, we want to skip duplicate numbers. So let's say while nums, would it be L? While nums L equals nums L plus 1. Let's see, how do we do that up here? Well, nums L, let's spread that out a little bit. While nums L equals nums L plus 1, increment L. Okay, so it's a look ahead, but we're gonna increment it so that we skip over duplicate second numbers. You know what? We also need to check and make sure that L is still less than R. All right. Well, L is less than R, and nums L equals nums L plus 1. That means we have 2 of the same number in a row. Increment the left index so that when we increment it down here, we're going to get a new number. All right, and we're going to do the same thing. We need to do the same thing for the right pointer. So while L is less than R and nums R equals nums R minus 1, then decrement the right pointer. Okay, so that's the algorithm, I think. Let's try and run it. Compile error. Line 7. Looks like there's a typo there. Go back up to line 7. It's line 7. Oh, okay, right here. That should not be a curly bracket. All right, let's try it again. Let's see. Okay, there's an extra curly bracket. Okay, let's take that out. And run it again. Missing return statement. Wait a second. Didn't I put a return in here? Oh, I didn't. Okay, so the return is going to be, let me line up the brackets here. The return is going to be right here. Public. That's that, and that's got to be here. Return triplets. Okay, now let's try it. Okay, basic test case is accepted. Let me move this back a little bit. Scoot this over so we can see what happens on the submit. And go. That accepted. Okay, 25, wow, 25 milliseconds. So maybe they give you some extra time here, 25 milliseconds, but they give that as a really good time. Although it looks like pretty much everybody's getting the same basic time. This is funny here. This one, they're all flat except it's like nothing except 5% used 838 milliseconds. All right. I don't know. Is that the O of n cubed algorithm? Anyway, so this is rated as medium. Let's go back to the description. But I would say that this is, if there's a range of mediums, this is on the hard end of medium. So, yeah, okay. Anyway, feel free to like, subscribe, and see you next time.